Welcome once again. In the previous sessions, we have already seen how to schedule jobs on single machine with many number of jobs in queue, and we already saw that how the job sequencing is done on two machines with a number of jobs. So now let us see the scheduling of n jobs on given three machines. That is n bar 3 scheduling. So it is it is called n bar 3 scheduling, which means that there are n number of jobs are there, and we are given three machines. So the constraints are, so we have to use all the three machines in the following manner. So only three machines are involved, that is M1, M2, M3. So let us name the machines name like this. So M1, M2, M3. So these are all the machines, three machines. And each job is processed in the prescribed order. So first M1, second M2, and third M3. So this is the order of the machines to be used. So no pausing of jobs is permitted. As already we see the same rule in the two machines, we are applying the same concept, same constraint here also. So no pausing of jobs permitted. Same order of machines use is M1, M2, M3. Then the exact or expected processing time on three machines should be given. So only based on this scheduling for the given jobs on the given three machines can be done. And again, we are going to use the Johnson's method for sequencing the jobs. So let us see, understand this problem by using or taking up a simple numerical example. Okay, so in the screen you can see that, so there are some 5 jobs are given. So J1, J2, J3, J4 and J5. So these are all the 5 jobs given, and we are having 3 machines, machine A, B, C, right? So these are all the 3 machines A, B, C, and there are 5 jobs J1 to J5. So the completed hours, that is the hours needed for processing these 5 jobs in each machine, is given in this table. So our aim is to find the optimum sequence of these 5 jobs, and to find the total flow time and the idle time for each machine, that is a machine A, machine B and C. Right? The condition is all the jobs to be processed in ABC, and the order to be A, second B, third is C. So that is the order. So let us see the problem. 5 jobs are to be processed on 3 machines. The processing times in hours are given in the table, and we have to find the optimal sequence of the job so that the total elapsed time is minimized. So for that we are using the Johnson's rule, right? So these 3 machines, so here this is the table which contains the required number of hours, processing hours in each machines are given, and with this table we are going to construct, assuming that only there are 2 machines are available, such that, so if I am keeping 2 machines named G and H, and for this G and H, if I am calculating the machining hours of each job, so I have to create one table such that the G will contain hours for job 1, such that the hours of the A and B will be summed up, that will be used for the G. And for H machine, I have sum of this 2 and 3, that is for the B and C machines hours will be clubbed together and make a single hours for processing. So likewise, So each jobs, if it is to be processed on the new machines G and H, so the new hours will be formed like this. So job 1, job 2, job 3, job 4, job 5. So when it is processed on the machine G, first two of A and B will be clubbed together and it forms the hours in G, and B and C clubbed together, it will form the second machine H. Likewise, all the jobs are calculated assuming that the jobs are processed in the new two machines G and H. Now we can see that the problem is now it is simplified to a two machine problem. So we will use the same thing for getting the sequence in the two machines problem. So that is n by n bar 2. So that concept will be used here, and here I am going to use the G and H machines timing, and for each jobs we have to calculate the sequence. Now, so as usual we will see what is the minimum hours of processing needed, and that will be whether we have to see whether it is on the machine 1 or machine 2, and accordingly the sequence will be recorded here. So as there are 5 jobs, so we will make one 5 box here, a linear 5 box, and if the second machine is having the minimum least hour, so that will be on my right end. If any machine 1 is having a least hour, that will be on my left first, right? So these both ends will be filled accordingly the level of the hours required. So here in this table, so we can find that so the value is 5 hours on H is for job 1. So that will be the least, but as it is on the second machine, so I have to fill it in the first of my right end. So this J1 will be written here because so that is on the second machine and it is the least hour. So J1 is sequence here. Now after 5, so we can move to the other list. So that we can see that there are 8 is the hour for J2 and J5. So J2, J5, so if you see that the total hours for J5 it is 18 and total hours for J2 job 2 is 16. So let us take this job 2 is my priority, and as we can see that 8 is coming in the first machine, so that J2 can be placed on the left end. So the J1 as it is comes on the second machine, it is placed in the last box, and J2 as it is comes in the first machine, so it will be placed in the second. Similarly, we can see the other jobs. So J1, J2 is already arranged, and J3, 4, 5 are considered like this, and we can form the order either from the right end or from the left end. So after filling all this, we can find this, the jobs J2 will be the first one, and J5 will be the second one, and J4 will be the second, third, J3 and J1. So this is the order, and these orders should be processed for the given 3 machines, that is A, B, C. So we will calculate what are the timings or what are the processing timings needed for each jobs in each 3 machines. So let us create one table of machine hours. So after finding the order sequencing, that is J2, J5, J4, J3, J1, so this order will be first written on the table, and what are the machining hours needed for machine A, machine B, machine C, that will be written alongside of the jobs. So for J2 in machine A, so it needs 7 hours. So initial time on machine A will be 0, and it requires 7 hours in machine A. So after this J2 completes in machine A, and it will go to machine B. So in machine B, the J2 will be having only 1 hour. So at 7 it comes to B and plus 1 hour, so it ends, that is the 8th hour, it will completes its process in B. Then after 8th hour, then the job will goes to the C machine C, so which is having 7 hours. So this 8 plus 7, so total time required for completing job 2 is 15 hours. So we can see that, so 7 hours it will process in machine A, and 1 hour in B, and 7 hours in C. So totally 15 hours needed for the job J2 to be completed in all 3 machines. Then after the first job in machine A is completed, the next job, which is J5, will be loaded. So after 7th hour, the job 5 will be loaded in the machine A. So 7th hour, it will be loaded J5. So J5, again, it needs 5 hours in machine A, right? So J5, 7 hours, 7th hour it is loaded, plus 5, so it is 12. So the time completion of the job 5 in machine A is 12 hours. So after 12 hours, again it will goes to B, and it reads, so J5 it needs 3 hours. So 12 plus 3, it is 15 hours needed in machine B for the job 5. So after 15th hour, it goes to C, and it needs another 7 hours. So 15 plus 7, so 22 hours. So the total time required for completing J5 in all A, B, C. So but it starts only at 7th hour and ends at 22nd hour, right? So likewise we can fill the all other processing hours in this table, and we can see that the machine A starts from 0th hour and completes at 15th hour. Then remaining hours will be that is the idle time for this machine A. So we will calculate like this. So J2, it needs 15 hours in completing all the machines. J5, 22. And you can see that the machine A is not idle with all these consequent jobs, because it is sequentially it is loaded so that it will continue its operation. But whereas in B, you can see that even though the J2 completes its work at the 8th hour, but the next job is loaded only in 12th hour. That means that there is a delay of 4 hours. That is the idle time for this 4 hours is here for this machine B. And similarly, even though if the second job is completed at 15th hour, but the next job comes only at 21st hour. So that means that there is a 6 hours delay. So it is idle for 6 hours. So like that, so the idle time of the machine with the previous completion is calculated. So that will be given as idle time. And the total idle time can be calculated for this machine. That is the total time for completing all the jobs. We can find that this is 40 hours. So this 40 hours is needed, and the machine A completes its operation at 32 hours. So the remaining hours will be its idle time for this one. So 40 minus 32 is the idle time for, that is 8 hours is idle for machine A. And similarly, we can sum up all the idle time of B, and we can see that, so 25 hours is the idle time for B. and also we can calculate the idle time for C. So it comes around 12 hours. So the total hours, the total flow time for completing all the 5 jobs in the given 3 machines is 40 hours, and the idle time for each machine is calculated like this. So A, B, C. So A is 8 hours, B is 25 hours, and C is 12 hours is idle. So using Johnson's rule, we have find out the optimum sequence of jobs, and the jobs are going to be processed in the machine A, B, C, and this is the processing time. So this way we can find any number of jobs in given 3 machines can be sequenced for finding the optimum flow time. So this will be carried out for any number of jobs. So with this we will come to the end of this session. So rest we will discuss in the next class. Thank you.